Hi there. In this video, we're going to be going over logarithms and some rules and properties to help solve, simplify, or whatever you'd want to do with them. Since it's not a simple process like addition or subtraction or whatever, what is a logarithm? Just in case you need that information. Well, it's basically when you want to find a variable that is an exponent. So in here, b to the x, b can be a number, a fraction, another variable, whatever, but we're trying to find x. Same with a, it can be anything. Through the video, I'm probably going to be referring to them as just numbers, but keep in mind they can be anything. Anyway, in this instance, we have b to the x equals a. Well, we just rearrange that to be log, this is referred to as base b, so log base b of a equals x. It's kind of like a square root, where you have the square root of a, or whatever you have. Since it's not a simple process, it's almost like you're writing a statement where you're saying, what is x when we have a number to the power x that equals a? When we have a number b to the power x that equals a. Since it's not simple, you do need a calculator or some guessing and checking to find x, unless you have a very, very nice case, like something like 2 to the x equals 4. Well, this is pretty easy to figure out because it's how many times do we have to multiply 2 to get 4? That's just 2. So x equals 2. You may also think, why don't we just take the x root of both sides? So b to the x equals a. Take the x root. Well, then we have b, but now it's the x root of a. So we still haven't really found x. So this is how mathematicians have developed a system to finding x. And if it's not a nice case like this, then it's going to need a calculator or guessing and checking. Now on to the rules. Some are simple, some not so much. But here we go. The first is known as the product rule, which is log base b can be anything, times a times c, excuse me. Well, a and c again can be anything, but in this instance we change it to be log base b of a plus log base b of c. It's an addition of logs with the same base, b, where then it's log base b of a, log base b of c, a times c. So the multiplication turns into addition. I will be making a video for each rule, maybe one for 2 rules, depending. But this video is just to show them. Anyway, since it's multiplication and addition, the order doesn't matter. That's not quite so true for the quotient rule, it's called, because we're taking the quotient. So log base b of a over c. It is very similar, though, where it's log base b of a minus log base b of c. They have to be in this order in this instance, but it's basically the same. So when they're being multiplied, it turns to addition, divided, turns to subtraction. Next is the power rule, where it's log base b of a to the c. So what's inside the logarithm is being brought to a power. Here, it's pretty simple. The c can just be moved outside. Again, I'm making videos to show how this happens. Next, I like to call them the cancellation rules. If we have a variable r, so there are 2, we can say log base a of a to the r. So again, what's inside the logarithm is being brought to a power. And the base and what's inside the logarithm have to be the same. And then similarly, we can have a to the log base a of r equals r. This is for if you ever have a variable or a number and you need to change it into some kind of logarithm involved. There are some cases in various maths, but not super common in others, so it's nice to keep in mind. Anyway, next we have some interesting properties involving 1 and 0. So if we have log base a, that's supposed to be a. Let me fix that. Log base a of a, it equals 1. So if the two are the same and there's no exponent or anything, it just equals 1. Well, you can look at it as a to the power of 1 as well. So that's a nice little link up there. Anyway, log base b of 1 equals 0. I can explain this very quickly because b to the 0 power equals 1. So if we change that into logarithm form, we would get this. So log base b of 0 equals 1, so that means the variable must be a 0. So if it's ever a 1, it will equal 0 there. Now they get a little bit more complicated. So here we have log base b of a, pretty standard. Then that's being multiplied by another logarithm, but this time it's log base a. So the base is the same as what is in the logarithm here. So log base b of a, log base a of c is some other number, it can be anything. Well, in this instance, then we get just one logarithm, which is base b of c. So it takes the base of the first and what is in the logarithm of the second. Next, we have log base a to the m. So again, the base has a variable. So log base a to the m of a to the n. So the base and what is multiplied have the same number there, but then what they have as an exponent is different. In this case, we get n over m, where they can be anything except n cannot be 0 because that would be undefined, anything divided by 0. If m was 0, that's log base 1. So if you ever have log base 1, this property will not work. Now we have log base b of a. It's pretty standard. Another way of writing it, though, is 1 over log base a of b. The a and b switch places. And with this property of exponents here, which there are a few instances here, especially on this side, where this can be used to rewrite stuff. So over here, if m was a negative, we could write it as 1 over a to the n as the base. That might be a little bit more unpleasant, though, so do be careful. But here, we know we can write it log base a of b to the negative 1 power. So that makes it look a little nicer, I would say. Down here, again, here's another negative exponent, so we could write this as b 1 over b to the a. So log base 1 over b to the a, or log base b to the negative a of c. In this instance, the a gets moved around a little bit. So from there, it gets pulled to the outside and becomes negative. So it's negative a to the negative 1, which of course can be written as 1 over negative a. Then that's negative a to the negative 1 times log base b of c. So log base b of c stays the same. A just gets moved out, gets brought to a negative 1 power. Now we get to some special instances of logarithms. Log base e. If you don't know what e is, it is a very special number, like pi is a number 3.14. E, I'm not going to go over here, but I am going to make another video of it. If it's not out now, it will be out eventually. But e is very special. In this instance, log base e gets its own special term, ln, which is the natural logarithm. So if you ever have log base e, that's just ln. Or if you have ln, you can know that's log base e. So you can know you can manipulate it like with everything else. Now, log base 10. Why is this special? Well, because on calculators, you'll just have a log button, and you can't really manipulate the base. Pretty sure on all calculators, if not all, most, your logarithm button is base 10. You should have a natural logarithm button as well, which of course is log base e. But log base 10 on your calculator is just log of a, or is just the logarithm. Now, with that being said, you're probably wondering how you do manipulate the base on your calculator. Well, that's this property here. If you have logarithm base b of a, you can rewrite it as log of some other number. D can be anything. D can be 10. So that's log of a over log of b, the base. So that's how you would put it into your calculator. That's it for this video. Again, I'm going to be making videos for each and every rule, maybe 2 rules